Hello everyone, welcome back to another video. In this video we're going to tackle exercise number 57 in section 6.4. So, to begin, notice that what we need to always do in these sorts of problems is we need to first factor everything. So maybe I'll factor this denominator here. This is a perfect square. Check that this is the same thing as x plus 1 squared. If you're not sure why that is, review the factoring videos from earlier. And then in the denominator here we can pull out a 3, leaving us with this. And in the denominator over here we can factor out a 5. Okay, so that leaves us with all of this, and now what we need to do is we need to determine a good thing to do would be to determine what the domain restrictions are. So the domain restrictions are that x cannot equal minus 1. This is our one single domain restriction for this problem, because notice all of the denominators involve x plus 1 and no other kinds of expressions, so therefore x equals -1 is the only domain restriction for this problem. So now taking this a little bit further, let me pan down a little bit. Now for the next part now, what we need to do is we need to get the we need to multiply the entire equation by the least common multiple. So let's do that. So the least common multiple in this case is going to involve x plus 1 for sure, right? So we need to multiply both sides of the equation by the least common multiple. Maybe I'll shove some parentheses just for emphasis. And now just to straightforwardly determine what that least common multiple is, we have x plus 1 squared here. We've got x plus 1 here, x plus 1 here. So x plus 1 squared, that's the highest power of x plus 1. That will be the first part of our LCM. And then the second part, notice we've got a 3 and a 5. So the least common multiple of those two numbers is 15. When they're both prime, or when they're relatively prime, when you're dealing with two numbers that are both prime like this, you can just multiply them to get the LCM. But anyway, stepping away from that, now this is our LCM, 15 times x plus 1 quantity squared. So I'm going to multiply this side of the equation by that as well. So multiplying both sides of the equation by the least common multiple, which is 15 times quantity x plus 1 squared. Now this looks a little bit confusing, but let's see what happens after this. So maybe I'll use a different color just to emphasize what's going on. So for starters, this x plus 1 squared here and this x plus 1 squared here, when we multiply, cancel. So all we're left with is 15. That's pretty much what was intended. Oh, here, let me use black now. 15. So 15 is what's left on the left-hand side. On the right-hand side, now we've got to do 15 times x plus 1 squared times 3 times x plus 1. So I have to be a little bit careful when I'm canceling, because I really need to distribute this through both of these terms. But starting with this one, we have an x plus 1 in the bottom, and we've got two of them here, right? So there's going to be one left over on the top as a result. So what we're going to have is we're going to have, I'm going to write x minus 1 in parentheses, and then we're going to have 15 in there as well. So maybe I'll throw the 15 in the very front, actually. 15 times x minus 1, and then remember that there's the 3 in the bottom. And yeah, I'm going to write out all these steps. X plus 1 squared here. X plus 1 in the bottom. I'll do the canceling in the next step just to make it a little bit easier to see what's going on. And then next, we're going to have 15 times x plus 2. Again, we're just distributing x plus 1 squared. Over, now this is over 5 times x plus 1. Okay. So that's the distribution step. That's multiplying both sides by the LCM. Now let's see what happens after canceling. So I'm going to pan out a little bit just so we can see a little bit lower. Okay. So now we've got 15 equals. So yeah, this denominator will cancel. We'll just be left with just a single 1 as the exponent. And then 15 and 3 cancel. We're just left with a 5. So we get 5 times x minus 1 times x plus 1 plus, now on this side, what's going to cancel out is we're going to have x plus 1 canceling with one of these guys up here. So I just cross out the 2. And then 15 over 5 is 3. So in essence, after writing all of that, we have 3 times x plus 2 times x plus 1. Okay, so far we've multiplied by the least common multiple. We've canceled things out. The next step is we should probably take this and set it equal to 0, distribute this stuff out, see what we get. Let's see if we get a nice factorable quadratic out of it. So I'm going to, distribute the 5, or rather I'm going to foil this part that's blue underline, and then we're going to distribute the 5 through afterward. Similarly here, we're going to foil what's in here, and then we're going to distribute the 3 through. Doing that, we get 15 is equal to 5 parentheses. Okay, I'm going to foil this. We get x squared minus 1. The inner terms will cancel. Here we get 3 times x squared. We're going to have x times 1, that's 1x, and then x times 2, that's 2x. So we get 3x in total. Doing 2 steps at once there. And then next we've got 2 times 1 is 2. Okay, now we're in a good spot because now we can distribute this stuff through. Maybe cancel some things out or combine some like terms and see what we're left with. So what I'm going to do also is subtract 15 in the same step. Okay, so after all of that, we have, and then I'm also going to move this to the left-hand side just because it's a little bit nicer on my eyes. 5x squared minus 5 is equal to, or sorry, not equal to, but plus 3x squared, so we're distributing, plus 9x plus 6 minus 15. And remember what all of this stuff equals is 0. Let me pan down to give myself a little more room. All right, so now we've got some like terms to combine. 5x squared and 3x squared is 8x squared. We've got 9x, that's kind of a standalone linear term. And then we've got minus 5 plus 6 and minus 15. So minus 5 plus 6, that's 1. 1 minus 15 is minus 14. All right, now we've got a fairly complicated looking quadratic. I don't see a greatest common factor to pull out. So the next thing we might want to do is we might want to try the AC method. So for the AC method, remember we take 8 times minus 14. We compute what that is. I'm actually not sure what that is off the top of my head, but one way to compute it is to do 14 times 10 and then to subtract 28. So that gives you 112. Negative 112, that is. And now we're looking for the factors of negative 112, which would sum to positive 9. So the factors of negative 112, that would sum to positive 9. Well, just not thinking about it for too long, I see that these give me, if I took positive 14 and negative 8, for example, that would be really close to what I need. That gives me a sum of negative 6 when I add 14 and negative 8, or sorry, that gives me a sum of positive 6. So when I add 14 and minus 8, I get positive 6. Not quite positive 9, right? But if I go up one more, 16 times, what would it be, times negative 7. That works. So check out that 16 times minus 7 is indeed minus 112. So now what we're going to do is take this over here. We're going to write 8x squared. Maybe I'll pan down just a little bit more. 8x squared. And then we're going to break up this plus 9x into minus 7x plus 16x minus 14, and that's equal to 0. Now we need to take the greatest common factor out. The greatest common factor here will be 2. We'll get 8x minus 7 on the inside, which matches with the previous parenthesis, which isn't a coincidence at all. That should happen, provided we did everything correctly. Now we factor out the 8x minus 7. All right. Good. And now remember this equals 0. So the last thing we got to do is set each of these equal to 0. Well, not the last thing, second to last thing. We got to set each of these equal to 0. So we get x is 7 over 8 from this one. We get x is negative 2 from this one. So these are two possible solutions. Notice I use the word possible because we're not 100% sure that these work out. But remember, our only domain restriction from the get-go at the very top up here was that x cannot equal minus 1. That was our only restriction. So since neither of these are minus 1, we can just readily conclude these are the two solutions to this problem. There are no other solutions, and both of these are indeed valid because neither of them equals minus 1. So that's the end of this problem. It was a little bit longer, more involved. I wanted to give you guys a better look at, or kind of just a more complex look at or just more complex problems of this sort. So anyway, we'll see you guys in future videos. I hope this was helpful, and have a great weekend.